All right, so the last couple days we've been working on Euler paths and Euler circuits, red dots and blue dots, and trying to figure out if you can trace over a graph and end at the same place, or if you can trace over a graph and end at a different place. And sometimes you can't trace over a graph unless you pick up the pencil. So now today we're going to start looking at some applications of it. And the first two applications are talking about a mail carrier and a security guard. So I want you to think about having a street. I'll do it over here for the mail carrier. And on that street, like a neighborhood street, you have homes on one side, and you'll have homes on the other side. These homes kind of look like trees. I apologize for that. So if you have homes on one side and homes on the other side, if you're the mail carrier, you're going to have to walk to each house on the red side, and you're going to have to walk to each house on the green side. So the route that you're going to have to go is you will have to go down the street once, and then you're going to have to go up the street on the back way. But if you're a security guard and you have that same set of homes on the top and the same set of homes on the bottom, and you're a security guard with a flashlight, okay, as you walk, you do not need to walk on both sides because your flashlight can just shine as you walk. So you can shine looking at some red, looking at red. You can shine and look at some green, all while you walk it just once. So his path, I don't want to say his path, his route, he can do all of this street in one time through, where the mail carrier is going to have to go 2 times through. So I want you to have that in mind as we start looking at the next couple problems on the next couple pages. So on page 2 of your packet, we're going to do a mail carrier problem. And I'm showing you a large neighborhood where there are some streets that have houses on both sides, and there's some streets that have houses only on one side. So if I draw in the road, I can easily draw the road part. I'll put that in black. But I actually have to add more pieces to this because for the mail carrier, I'm trying to represent how many times he has to go on each road. So when he is, I'm going to highlight it first so you can kind of see the idea. All of these here, that side looks like here, looks like all of the outside, all of those are where there's houses on one side. But in the middle of the neighborhood, these blue roads that I'm trying to highlight for you, the blue roads, you actually have houses on both sides. So as the mail carrier, on these, you're going to have to walk those streets twice. Because you have to go down one way and back up the other side of the street. But on the yellow parts, you only have to walk these once. So I need to rechange this neighborhood, and I want to represent walking the yellow only once and walking the blue twice. So to do that, what I'm going to do is I want you to think of me adding in a walking route. So that extra blue is saying I got to walk down that side and back up that side. I have to walk down and back up that region, and down and back up that region, and down and back up that region. So notice on the blue part, I've actually made it walking each road twice. One down the black, one back up the blue. So if we want, we can kind of just relay this as I'm going to draw a rectangle in the space that I gave you. I'm going to give you the dots, kind of how they're situated. Okay, but I'm going to add in, it's going to be from this middle part, I want you to think of it as 2 loops. because you have to walk down one side and up the other side. Okay, so if you're still trying to see the highlighted part of this, this is the outside part of the story where there's houses only on one side. And the inside parts, you're going to walk this part twice, this part of the street twice, that part of the street twice, and that part of the street twice. So I actually had to add in a couple more lines, if you will, so I can represent the mailman walking. Okay, so let's think about that mailman again. Here he is, and let's say he parks at this corner right here. The question is, if you park your post office truck there, can he walk through the whole neighborhood, delivering all of the mail to each house, and land back at his truck? Because ideally, he could park there, walk the whole neighborhood, get a good exercise, and then come back to the truck. It would not be ideal if his truck is here and he walks through the entire neighborhood and ends up here. Well, then he's going to have to retrace his steps back to his truck, hop in, and go. So what he's really hoping for, the mail carrier is hoping for a circuit. Mail carrier really hopes for a circuit. If he has a circuit, he can leave his Jeep there, his car there, his truck there, walk through the entire neighborhood, and end back at that truck. So, just like yesterday, we're going to now start counting how many roads or how many lines come out of each dot. So I'm going to start counting them. 2, 4, 2, 4, 2, 4, 2, 4, and a lot here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 2, 4, 2, 4, 2, 4, 2, 4, and an 8. What you'll notice is all even dots. So all even dots. So we can say this is a circuit. Okay, so he can in fact park at that bottom left corner, and let's watch him trace this out. And since he is happy that he can end back at his truck, I'm going to pick smiley faces and I'm going to trace it for you. So he can start there, go, 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 come in, loop out, go again, go in, loop out, go again. This is him delivering mail to the neighborhood. And if he decides to do that route, he can get back to his car and drive away after he delivers all of the mail. So for a mail carrier, you are hoping for a circuit so you can start and end at the same place. And the big part, the key to this whole story, was how I added in those extra kind of lines. It's like drawing in another road for the interior, because he had to walk down and back on those streets because there's houses on both sides. So now we're going to take a look at one that involves the security guard. Same neighborhood with the security guard. Okay, so for the mail carrier, we did it on the top of the page. Now we're going to look at it with the security guard. Okay, so let's keep that in mind. This is where we're going to look at a security guard idea. Okay. And so we're going to start, and we're going to hope that he can walk through, and he's also hoping for a circuit as well. So he wants a circuit as well. He wants a circuit as well. And again, why would he want that? So then that the purple security guard, wherever he starts, okay, if he has a yellow Jeep, okay, he hopes that if they park here, he can go do his work and hop back in his car afterwards and drive off. He doesn't want to retrace steps, because then that's just wasting his time. He wants to kind of get in and out. Now, as you look at this road again, if you remember, we talked about the inside part. The mailman had to go down both sides of the street. Security guard, though, he doesn't, because remember, as he's walking here, yes, there's two sides of the street that have houses on it. But as he walks, he can just look there, look there, everything's clear, no burglars, no robbers, and we're doing okay. So he does not need to retrace that road at all because he can just shine the flashlight on both sides as he walks through it. So for this one, you don't have to add any more extra lines. His story is he wants to walk through all of these streets. He wants to walk through all these streets, and he does not need to repeat anything. So we're going to keep it this way with not adding in any extra road. So it's almost, I should have maybe started with this one first because we're not adding extra lines, and we can just look at the road as is and start counting for evens and odds. So we're going to start, and we got 2, 3, 2, 3, 2, 3, 4, 3, 2. Okay, so if you wanted to convert those into red and blue dots, you would have evens are red. So I got red, 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 red in the middle, and blues on the odds. And we'll notice that we have more than 2 blues, so more than 2 blues. So I'm not a circuit, I'm not a path, I'm a neither. And I want you guys to remember what a neither means. A neither means I'm going to have to pick up my pencil, or it means I'm going to have to retrace my steps. So I want you to remember, neither means either I'm going to have to pick up my pencil, or it means I'm going to have to retrace some roads. And the part that he doesn't like is retracing roads means more work for guard. And let me show you what I mean by that. So let's say I put the guard, let's say I start at one of the blue dots. Okay, so if I am the guard and I walk, this will be his path of walking. I will do it with a crayon, and we'll go purple, because that's him. He covers this part. He's good. He hasn't retraced anything. He goes down. He can go. He can go. He could go up. He could go over. He could go over. He could go there. And here's where the issue is. He gets to the middle, and now this is where he's going to be mad. He's going to have to walk through there. So far, good. He's not retraced. He's not mad. But here's where madness comes in. I got to retrace to here. And then I'm going to go back down. And then I got to retrace to here. So that orange is him being fiery and mad. And then he's going to retrace here. Or not retrace, sorry. Do purple there. He's fine with that. That's the first time through. But then now he's mad that he has to retrace to here and retrace back up to his car. So in this whole route of checking over the neighborhood, he's still forced to trace over some roads more than once. And that's not what he wanted. He would love to just walk through it once, call it good, hop in the car and go home. But all those orange marks are where he actually had to do more work. Now for the mail carrier, those orange marks he had to do anyways though, because he had to go on both sides of the street to deliver the mail. But for the security guard, he actually had to do more work here because it wasn't a circuit. All right, so we're going to look at another neighborhood here, and we're going to look on the top of page 3 of your notes. And let's start with the security guard. I think I should have done that on the first one to begin with. So the security guard, there's a lot of blank space on your page. I'm going to focus on the right side of that where it says security guard. Okay. Security guard, his job, his goal, walk through that whole street, all the streets. He doesn't want to retrace any of the streets. He doesn't care if there's more houses on one side or houses on both sides. His goal is to walk through the entire street. So I'm just making this up. He would just go, he is happy. He hasn't had to retrace anything. He hasn't retraced. Okay, right there would be an issue. He's mad. Now he's going to go again. He's mad. He's mad. He's wasting his time. That's good. Oh, no, he's mad. Okay, that's good. Do you see all the madness that happened from that? I'm going to try it again, and hopefully this is visual for you, even though I'm not in the classroom. So I'm going to try where he starts, let's say, here. So if that's his Jeep, that's where he wants to end. If I go smooth, I am happy because I'm doing my job. If I scribble it, that means I'm retracing and I'm doing more work. So I'm not happy, I'm mad. Okay, so let's start. So Jeep. Let's say he goes here, he goes here, he goes here, he's going here, he's going here. He's so far good. He's not mad at all. Good, good. He had to retrace steps there. Here. He had to retrace steps there. He can be good, he's good, he's good. Oh no, now this is a long retrace. He's good, he's done. But if he ends here, is that where his car is? No. So he's going to have to retrace one more time to get back to there. So if you notice, in that story there, it looks like he got to retrace 4 times because he's not happy, okay? Because he did more work doing it. So if we want to calculate how many times he'd have to retrace, this is the trick that you can do. So we're going to actually copy the entire story back down, okay? We're going to try and get this as close as possible to what it looks like. Okay. So I think you might have to retrace 4 times, and we're going to try and see if we can figure out how I know it's 4 times without actually doing the story. So I retrace the entire city grid of it. And as usual, we're going to count the evens and odds of it. So I got 3, 3, 2, 4, 4, 4, 3, 3, 3, 3. Okay. So if you wanted to color code dots, evens are red. And you're always hoping for reds. Or you want 2 blues. I have 2 blues there, but now you can see there's a lot more blue than I want. So more than 2 blue. So I am a neither. I'm not a path and I'm not a circuit. So the question is, he wants a circuit. So guard wants a circuit. So we're going to try to force a circuit. And we're going to force a circuit by adding in the retraces. So if you want a circuit, you have to change all blues to reds. So I need to change all blues to reds. So to do that, what I could do is I could add in an extra road here. Let me change it to a different color. Let's say I add in an extra road here. Now when I say add in an extra road, I want you to think he retraced that road. If you add in that yellow road there, what's nice is this 3 becomes a 4. This 3 becomes a 4, which means those blue dots are now red dots. Okay? So I could also do it on this part here. I'm going to add in a road here. And again, all road means is I'm going to retrace. So if I add in a road there, that 3 becomes a 4. That 3 becomes a 4. And this now becomes 2 red dots. Okay? So I have lots of red dots, but I only have 2 blue dots. So that means I'm still going to have to retrace. So the last retrace is if I put in an extra road here. Now that means he's not physically making another road. He's just going to have to walk that route more than once. I can change that to a red and a red, because this 3 becomes a 4, and this 3 becomes a 4. So in this way, it looks like I added in 3 yellow roads, 3 yellow roads. So this is 3 yellow retraces. Okay, so I actually think I can do this neighborhood by only retracing 3 times. Now over here, when I first attempted it, over here, how many retraces did I have? 1, 2, 3, 4. So I had to retrace 4 times. That's me going with the red scribble. But now I did it more systematically, and it looks like it's only 3 retraces. So let's try that out. So imagine again that we have now a happy guy who starts there. And I think I'm going to be able to walk through the neighborhood and only retrace 3 times. So I could go there, here, there. I'm good. I'm going to be here, up, down, there, over, boom, 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 up, down, and around. So that's a lot of smiley faces. So I'm going to pull those off for a second. I started and stopped at the top right corner where that smiley face is. I started and stopped there. And if you look at how I laid out my smiley faces, I had to walk over those 3 yellow brick roads. And what are those yellow brick roads? Did I actually build a new road? No, it just meant I retraced. So for the security guard to do his job, he's going to be able to start wherever he wants, but he's going to have to retrace 3 extra roads to get back to where he started. My first attempt over here in the purple was I had to retrace 4. I was not happy. The next time though, when I did it with the math, I could retrace 3 times. We're going to look at a couple more examples on the next video.